So today's topic is quantitative composition of substances. So we are starting what is called the Molar concept. So the intro there is that the composition of compounds is an important concept in chemistry. So now, guys, when you hear the word quantitative composition of substances, the word substances to a chemist does not just mean a woman of substance, know how much substance is there. What this means for that there is no substance in what you are telling me, no. For us, substance is for elements and compounds. Those are the ones we classify as substances. So that's why there's that intro to say it's very important to know the composition of compounds. So most of the times we have numerical relationships among elements and compounds that we use to measure the exact quantities. So we have numerical relationships, especially in what are called chemical equations. Chemical equations, we'll do them next time, like when we come. So now for this one, guys, the most important for us to know is the mole. So the mole is the SI unit for the quantity of a substance. The mole is an amount which is familiar to units like pair. Pair means 2. Dozen means 12. N'abanensu bante balabomfya okutira gross by 144,000. So gross is 144. So now for the mole is related to this because it's also just like this, a group of a specific number of substances. So these are the things that are there. So we explain now the definition of the mole is that it is the definition of the mole is that it's an amount of substance containing the same number of discrete entities, which are elementary particles. These ones can either be atoms, molecules, ions, electrons, etc. As long as something is that exact number, then it qualifies to be called the mole. I've mentioned the electrons because they're not in the example, and yet we have moles of electrons. So as many discrete entities as the number of atoms in a sample of pure carbon-12 weighing exactly 12 grams. This definition, I've redefined it class 2. Definition akasoma. So the mole is the SI unit of quantity of a chemical entity, such as those mentioned. It is defined as the amount of substance that contains as many particles as there are atoms in 12 grams of pure carbon-12. So that's the thing. So one more, guys, contains a number. The number very big. Let's go back, Uku. So one more, not remember, I've already explained. So the mole contains that much. It was named as Avogadros number after a scientist called Ameldo Avogadro. So the Avogadros number is this big. Guys, if you have 10 to the power 23 substances of something, that's very big. So this is a very big number. If this zeros, 23 zeros, we're talking about this point moving this side, you're adding, if it was money, it would be so much. Because if you know, guys, 10 to the power 3 is 1,000. 10 to the power 6 is million. Now imagine 10 to the power 23. So those ones are so many particles. We don't even know how Avogadros counted them. So this Avogadros constant is the number of those particles that are there. So we always fix it. And we've stated that for purposes of our learning, we'll round off, not round out, I think 3 times, that we'll say 6.022 times 10 to the power 23 particles per mole. So the units we say per mole, because then the particles can be anything, electrons, atoms, all that. So let's explain. So for consistency, let's explain to say 1 mole of different elements. So 1 mole of an element contains the same number of atoms as 1 mole of any other element. What we mean is, if you have 1 mole copper, 1 mole hydrogen, okay, let's not put hydrogen because they're atomic. So if you have 1 mole copper and 1 mole sodium, those who have the same number of atoms. So 1 mole of something will have the same number. So 1 more copper, 1 more silver, 1 more gold, 1 more iron. Those will have the same number of atoms. However, those ones will have different masses. Those ones will have different masses. The mass of 1 mole is called the molar mass. The mass of 1 mole of an element is called the molar mass of the element. The mass of 1 mole of a compound is called the molar mass of a compound. So the molar mass for an element is the average isotopic mass of the element with the gram as the unit. So meaning the mass that appears on the periodic table, guys, inaitwa hapa periodic table. Hello, wabika kufe gram nishwa kwata 1 mole. Mayumvate? So the one that appears on the periodic table, different periodic tables, is very acceptable for our level to be rounded off. So trust your periodic table. If your periodic table is not rounded off, use the values that are there. Then if need be, we'll also be guiding you to say use rounded off values on a question. Then for a compound, the molar mass, there is a point here. For a compound, the molar mass of the compound can be calculated by adding the standard isotopic masses of the constituent atoms in the molecule of that compound. So meaning, if you have H2O, you will say hydrogen, 1 times 2, kayari abidam hydrogen, 2 grams, plus oxygen per periodic table is somewhere around 16. So 2 plus 16 is 18. So the molar mass for water will be 18 grams per mole. So the units is grams per mole. But we agree turasuminisha umuntu kudemba fe grams. Although ngorefa okushayina sarangani molar mass urefa tuwabika okusira grams per mole. So those are the things. So this relationship, guys, is very important. This is what we're trying to explain. 1 mole of this represents Avogadros number of these particles. 1 mole of atoms, molecules, ions, or electrons represents the Avogadros number of these particles. Meaning 1 mole of atoms is 6.022 times 10 to the power 23 atoms. 1 mole of molecules is 6.022 times 10 to the power 23 molecules. 1 mole of ions is 6.022 times 10 to the power 23 ions. So those are things. Meaning 1 mole of electrons will also be 6.022 times 10 to the power 23 electrons. So those are things. Here we are trying to emphasize that the mass you see on the periodic table, like those masses we are finding, we are finding isotopic mass. So those masses we are finding, like if say for hydrogen is 1.008 atomic mass unit, it means the molar mass is 1.008. You remove the atomic mass unit, you put the gram as the unit. And the number of particles in the molar mass is also the number of particles in 1 mole. Why? Because 1 mole is equivalent to the molar mass. A to the number relationship. To say 1 mole corresponds to the Avogadros number of particles. A to the So these are the examples. So what this book that I'm using does is that it does a conversion factor. I still emphasize that you guys were, when you were in secondary school, maybe chemistry was even your favorite subject, and some of you are corresponding. Some of you are using other methods. As long as they lead to the same thing, you can use them. I won't impose and say, no. This is science, we need to be progressive. Are you getting it? So, unless otherwise, unless the question you put Google, use this method. But no one will ever tell you about these modes. When we meet next time, I'll even give you triangles. The triangle that helps you to guide. But density, there's also one for the number of moles. So now, for this, guys, the question example 1, how many moles of iron does 25 grams iron represent? So you've seen that what you've been given is a mass. So meaning in your whatever you are corresponding, molar mass if we are sang up. And it should be such that its units should be cancelling with that. So you should write. So you say 25 grams iron. The molar mass for iron is from the periodic table is 55.85 grams per mole. Per mole means as the mass of 1 mole. So 25 grams Fe, then wapanga conversion factor paso. Cross sum line up. Then you say 1 mole iron punch 5.85 grams. Then this and that cancel. So in short, this will multiply times the 1 and divide the 55.85. So what you're going to have is 0.448 moles. I can get some noise. Whose mic is on? Whose mic is on? Then we go to the next one. A upper number, guys. How many magnesium atoms are in 5 grams magnesium? Na pena pamoja 5 grams. Then there's also mention of atoms. So once there's a mention of atoms, waishi what Avogadros number if we are sangwa popadi conversion factor. Then gram waishi what molar mass. So you correspond these two, the Avogadros number and the molar mass. These two are the ones you correspond. So you correspond them such that you are looking for atoms such that the grams are able to cancel. So you say 5 grams magnesium, you open brackets, you correspond. The molar mass for magnesium is 24.31 grams magnesium. Then that is equivalent to 6.022 times 10 to the power 23 atoms magnesium. The gram and the gram cancel. Then you multiply that one times that one. You make sure these things are in brackets up to that point. The things on top are in brackets, then you divide the thing at the bottom there. Then you get 1.24 times 10 to the power 23 atoms of magnesium. There should be that many. So that's the way it is. Next, what is the mass in grams of 1 atom of carbon? Mass in grams of 1 atom of carbon. Molar mass for carbon from the periodic table is 12.01 grams. It depends on what periodic table you're using. I've told you, don't beat yourself to say, okay. Students, they want to find a fault. But just know that there are different molar masses depending on where you are getting your periodic table from. So now, if we're saying 1 mole is this, then we're looking for atom. So 1 atom, it means in that atom, molecule, ion, electrons. In short, Avogadros number yala bomba, you use the Avogadros number. So 1 atom carbon, then you correspond. The molar mass, you're looking for mass. So you say 12.01 grams carbon over the Avogadros number. Upper guys, kuba careful, okay, this and this cancel. So 1 times 12. So it means you are just going to divide the 12 divide 6.02 times 10 to the power 23. This thing, everything should be in brackets because the answer you must expect must be negative 23. There was someone who failed an exam and assigned a positive. It was a negative. No, that's a very big error for chemistry. So those are the scenarios. So make sure you are very careful with your calculator. You use, especially you use brackets when you have powers somewhere. On your calculator, except this calculator that I have, but this EXP, EXP, it means times 10 to the power. So when you say 2 EXP3, it means you are saying 2 times 10 to the power 3. So you can use it on a sharp calculator, because this is a chemical. On a sharp calculator, EXP can be upside down, so EXP. So when you see that EXP, it means times 10 to the power. It makes it easier for you to work with things that are fast. So use calculators well, understand your calculator. That's why we don't encourage someone their exam. Paper phone. I just like use my phone, it's advanced. That's my phone. So when you meet a calculator for the first time, you get lost. So those are things. Because your phone is always in degrees, shining. So those are things. This question was an error, guys. This 23 should be a power. It should be times 10 to the power 23. So what is the mass of 3.01 times 10 to the power 23 atoms of sodium? So you will change for me when you are transposing, it will be transposing into a book. So that, you look for the Avogadros number, because atoms by Rumbra. So it means atoms, then the Avogadros number. So the Avogadros number contains one more. So that's 1 molar mass. So the molar mass for sodium is 22.99 grams. So the conversion factor, you make conversion factors everywhere. So you make sure that the molar mass is punched, because you make sure that the molar mass is on top, because you want the atoms to cancel. So you put Avogadro's number punch. So you put punch up 6.022 times 10 to the power 23 atoms sodium per mole per molar mass. Then you multiply. If it per mole, you divide if it punch. If you want, your math is very good. You can even cancel this to 10 to the power 23 and that 10 to the power 23. So to just remember the simple values and work them out. So the answer is 11.5 grams. The same for the mass of 0.252 moles of copper. Conversion factor. 1 mole corresponds to 1 molar mass. 2 moles correspond, then you cross multiply. It's very acceptable. 1 mole corresponds to 1 molar mass, then 0.252 corresponds to X. You cross multiply. It's very acceptable. But apart conversion factor, we are teaching the conversion factor, which says the molar mass for copper on top, the more 1 mole is at the bottom. And the beauty with the conversion factors where there's a more. Now you want to separate 1 more, because 1 more. Tawakabika po 2 more 0. So wabika 1 more, then you cancel. Ensure solve 16 grams of copper. The last example is the only one which is a bit tricky, because they are asking us of atoms in 1 more oxygen molecules. And if you remember, we said oxygen is a diatomic element. So it has diatomic molecules, meaning the molecules of oxygen ni O2. Itupema ni O2. Uyutupema ni O2 mukwai. So we'll find the batupelele ama molecules. So you find the molecules. So the conversion factor is this one, my matter, 1 more O2, then wabika 1 more O2 molecules there, 6.022 times 10 to the power 23 molecules of oxygen again. Then you multiply by a further conversion factor, which tells you that 1 molecule of O2 always has 2 atoms. Can you O2? So you have atoms up. If it was water, but how many atoms? This is what we of oxygen. How many atoms are there in water? It means we know that one molecule of water has 3 atoms, 2 hydrogens and 1 oxygen. But then 1 O2 only has 2 atoms because it's diatomic. So if to remember 1 more O2, then 1 more of 2 corresponds to Avogadros number of O2 molecules. Then we remember that 1 molecule always has 2 atoms. Then fya cancer molecule na molecule fya cancer, more na more fya cancer. Then you multiply everything on top. Punch parifia 1. Mapalo, do you want to say something? Mapalo?
No, sir, I just joined. So,
impressive work on Study Master, madam. You are allowed to even join late. In fact, na mudia tonse mavale toto patoto.
Thank you, sir.
Keep up, because we know that online learning has a lot of challenges. Now to see a sharp young lady doing so much magic after learning in online, even if the credit is to teacher of chemistry at grade 12, for me it's a plus for me, because it means most of you are learning these concepts and you're understanding and you are loving the chemistry. Madam, you have slayed the chemistry. Okay? All right, keep up. So the practice questions, these are for you to practice. I was actually recommending Mapalo. I went on Study Master and checked out. My only complaint is about Mapalo show. Say get up number 5. Machiringo of Kanapa number 8 points. I think if you know, you know. Okay, the essence of these practice questions are for you to know. Don't take them so personal, Yama practice. You know, take them personally for you to understand, but don't take them personally to think, kuchua firo kusanga practice, then kandro asa chonga, then it was a better results. No, I won't do that. But these same practice questions, similar questions like this, are the ones that will be assessment problems. That is not leakage nimi pera. The leakage is that the same way we're doing practice questions, that's how we also do the exams and the tests. So you must understand these concepts a lot. So I loved where she answered the question of what is the mass of 1 mole sulfuric acid. The mass of 1 mole is the molar mass. So she just started adding. Sulfuric 2 times 1. So those are things. Sulfur 32. Oxygen 4 times 16. Then she got something like 98. That was very impressive. The mass of 1 mole is always, I'm sure you know, guys, the mass of 1 mole is always the molar mass. So I'll give you the triangle. If you want to say physical reactive for Musangire, 2.5 moles of helium, the molar mass for helium is. What I loved about this way of answering Nyabe na Maparo was that she was also using the conversion factor. Meaning she went through what I was doing. Amba no konka. Yeah, the lady. Ladies, they do very well. Most of the times in our government, the ladies are best students. We've had more ladies best students than gents. But that's but if you government, I'm ladies. Then we also have had more extension-based students than regular. Now, advantages are popular. So when we see someone doing well more extension, is a potential best. That we should welcome for me lucky. My extension kashinga chief push cha kusambia leti, but mulachirika. So those are the scenarios. So now there are so many of these questions. How many atoms? So per the atoms, you remember Avogadros number. So we're looking for atoms in 1 mole. So you multiply this one 0.025 times, you open the brackets in mole. So 1 mole have a panchi, then Avogadros number. So you simply multiply the number of moles given times Avogadros number. Meaning, when you multiply the number of moles times Avogadros number, you get the particles you're looking for. That's the way it is. Then, where's practice 4? Yeah, where to the 4? Now, but to look at my practice 4. But Stephanie, the child go practice 4. Wow, Stephania. Stephania. So what Stephania has done there is practice 4 is asking for 1 kg. How many moles of sodium hydroxide are there in 1 kg sodium hydroxide? Remember that the molar mass is always in grams. So the clever Stephania multiplied the 1 times 1000, a quarter 1000. So 1000, then she multiplied times 1000 kg, then times, because she's looking for moles. The conversion factor was about 1 mole over 40. Apanga was started if it's almost rounding off to 40. So the answer is approximately 25. Tekwati ndemulumba fyomuntu uyu mayo nachaya. Hapa no 25. In fact, usangire fye eka. Oh, Nabamutinta. No. She's on one. She's on one. Because those are the
9
eh?
Nisangane.
Oh, muni pesa mbaz Joseph. Nice.
Banji.
Pesa banji tapada. But Joseph tamuli pota.
Refresh Maraimon.
Okay.
Refresh Maraimon.
I'll refresh later because when I refresh now, because of some time that you've been there, if it error, I'm sure you've seen the error when you spend on study master for some time. Keep up doing this, guys. It's impressive. Mr. Joseph, although I haven't seen your answer, if you have found that, big up. So, guys, the key thing that we've learned today is the use of the conversion factor. It's very rare for chemistry, it's applied. So most of the times you'll be asking, you'll be asked questions that that's required for you to solve. So you must up your game and your skill with regard to the conversion factor. So those are the scenarios. How many molecules of hydrogen chloride? Hydrogen chloride is HCl, acidic gas. Remember, this is hydrochloric acid. So now they're setting up another nomenclature. Sorry, but HCl gas. What's the name? Umuntu alemba hydrochloric acid ana mukumfa gwenu. Kanshi ndefu ainati alemba hydrogen chloride. Chimona H2S. Naina is hydrogen sulfide gas. These are very acidic gases. You don't need them in your center. And so these are the scenarios. So this one, we have 25 grams hydrogen chloride. Then we're looking for molecules. So we find the molar mass for hydrogen chloride. Chlorine is 35.5. So people for the part 36.5. Let me see. Ngapadi uchaide number shani. Number 6, practice 6. Okay. Practice 6. All right. So this is HCl. Mutinta. This is not the case. Hydrogen chloride, there's also chlorine. You just included hydrogen. So go and make a correction, madam. When you're forgetting the molar mass for hydrogen chloride, it should be 1.008 plus the one for chlorine, which is 35.5. I'm sure for you it may be 45.49 something. So add those, my own guys. So that now when you're multiplying, the conversion factor is okay. You said 1 more HCl, but what you have put on the molar mass is just the molar mass for hydrogen. You must also include the chlorine. Now you come Mutinta, man. Mutinta. It's a very good attempt, but there should be something that that changes there. All right. Bwana Innocent namusanga isangikirepo inasangapo. I'm reviewing your questions, your solutions. Very good work. You guys are doing splendid. Because we are reminding ourselves that we are learning online. So
I have a question.
Yes, Innocent.
I have a question, sir.
Yes.
Yeah, concerning the unit used in chemistry, can I be right to define more as a unit used to count particles in chemistry?
If you are going to use the word unit, kai not remember that it's defined as. So it's defined as the amount of substance that contains as many particles as there are atoms in 12 grams of pure carbon 12. Yapo easy. As many particles as there are atoms in 12 grams of carbon 12 isotope. That's
All right, thanks, sir.
That's okay. But if you want to say unit, don't just say it's a unit used in chemistry. You should say it is the SI unit of quantity of a substance. Apotma max test to free the cavetons. Why? Because it's the SI unit of quantity of a substance. Are you following, Innocent?
Yes, sir.
All right, cheers. Any other question? Guys. Any other question? Queries? Banda Aida. Bamishami mbobo mulilanda. Banda Aida, is there any question?
No, sir.
No?
Yes.
You have understood?
Yes.
Okay. You are too mute. You are too mute. Jumbe, Frederick. Are there any questions?
No, sir.
Okay. Mr. Bruno, are there any questions?
Meantime, no, let me go through them. I see the challenges.
Okay, okay, sir. Mr.
Sir.
Philip, yes?
I'm kindly asking if you can kindly go through on how to attempt question 6 because I'm having a challenge.
Who is this?
Mubanga Stephanie.
Question 6. Mayoba Mba Stefania. Oa, kashi mwabo, your accent jamfika kwati wako UK. Then question 6 for hydrogen chloride. So you have HCl. HCl. The first thing is you have been asked, in fact, you have been asked for how many molecules? How many molecules? Udowa tsanga nama mozga. I'm the one who has even lost you, I'm sorry. So this thing is asking you for how many molecules. So simply, you just get the molar mass of this, which is 1 plus 35.5, which will be 36.5 grams. So then you get 25 grams times, so what you should put there, Papanch Palava, 36.5 grams. Why? Because that's a molar mass. Are you getting it? But then, Pamulu, Palava, Palavench Pamul, never fire Pamul. Pamul Palava Avogadros number. Pamul Palava Avogadros what number. So Palava, you say 25. Tapada akakulembera pesa. I wanted to solve it in methods. Should appear. You know, we'll try it later. So you multiply. But Stephanie, you don't forget it. You don't become my Stephanie.
Yes, sir.
So you will say 25 grams times open brackets, punch pabe 40 grams. Pabe 36.5 grams. Pamulu, palava, Avogadros number, which is 6.022 times 10 power 23. Nshapa masanga man.
I have a question as well.
Yes.
I have a question.
Yes.
On the same question as you've demonstrated earlier before,
Yes.
can we as well use the conversion factor of which we are going to cancel the mass down of the same chloride of the conversion factor?
Yes. Okay, what you need to put down there is a mass. Stevo, you put the molar mass. So you say 25 grams times, open brackets, 6.022 times 10 to the power 23 molecules of hydrogen chloride over 56.5 grams hydrogen chloride, which is the molar mass. So at the grams from the molar mass and the grams from the 25 cancel. That's the case. Is that okay, Mr. Innocent?
Yeah, I've understand.
Okay, sir. Mwami olulimi. Mwami olulimi. Ngamwalande fukti mwatinya ba your future wife. It's understood. I've understood. Kabuga.
Understood, sure.
All right, sharp, sir. So, guys, this is simple. Go and perfect your skill. Go and perfect your skills. You can continue. Even as I'm waiting for this video to load, so that I can try to put it on YouTube while I'm still in school. What will happen is I'll still be going to a study master to go and check. So remember how to create a conversion factor. If you can correspond. So have a periodic table, staple it to your chemistry book, and copy the important concepts and try to practice. If there's nothing you can copy at least the formulas. When we meet on Monday, I'll give you the triangles. Enjoy your evening, guys. I'm very impressed with your progress.